Welcome to this lecture series in complex numbers. In this lecture, we'll look at the equation of a circle using complex numbers. And these are two problems about straight lines. All right. So fix a complex number z0 and a non-negative real number. Then the equation of the circle centered at z0 with radius r is given by, clearly it is all complex numbers satisfying precisely this equation. Right? Because the left hand side is the distance between z and z0 and the right hand side is r. So this is precisely the equation of the circle with center z0 and radius r. But we do not like modulus, so we square it. So we get that. And since r is non-negative, note that this is actually an if and only if. So if z satisfies this, then it satisfies that, and if it satisfies this, then it satisfies that, which is equivalent to saying z minus z0 times z bar minus z0 bar equals r square, which is equivalent to zz bar minus z0 z bar plus, sorry, not plus, or let me put that in a bracket, plus z0 bar z plus z0 bar minus r square equal to 0. Just did some basic algebra. So that is the equation of the circle centered at z0 with radius r. Great. Now we've seen that the equation of a circle with a given center and radius is of this form, meaning there is a suitable choice of w and a suitable choice of the real number m, such that this is the equation of the circle. This theorem says that everything of this form is a circle. So fix a complex number w and a real number m, then the equation, meaning the set of solutions of this, is a circle with center at minus w and the radius is this. All right, so let's do this. We have z bar w bar z plus w z bar plus m equals 0 if and only if z plus w times z bar plus w bar minus w bar plus m equals 0. So what did we do? This much is equal to that much, as can be found by basic algebra. So we get zz bar, or what am I writing? We get mod z plus w square equals w bar minus m. Okay, so if this is clearly a real number because m is a real number and this is a real number. So if this is negative, then clearly there is no solution to this equation, and hence you could say the locus or the set of points satisfying this equation is the empty circle or whatever. But if this is a non-negative real number, then we get that this is equal to minus m. So this step requires this equivalence is under the assumption that this is non-negative. All right, and clearly this is the equation of a circle centered at minus w and radius this much. Right, it's a very simple thing. Okay. Now let us see an application to geometry. So suppose we have two fixed points a and b in the plane. So a and b are given, and we want to find all the points p which satisfy this equation. So this means the distance between p and a, and that means the distance between p and b. Root 2 is just some non-negative number that I've chosen. You could have chosen any number and still everything works, but just I have chosen root 2, whatever that I like it. So we want to find all the points p which satisfy this. It turns out these points form precisely a circle, and this is not immediately obvious from just plain geometry. It will require some creativity to figure that out, but using complex numbers it becomes obvious. So what we will do is we'll think of a as 0, the most convenient choice for complex number, and b as just some complex number z0. Okay, so if p is thought of as a complex number z, then this equation is precisely asking all the points z which satisfy this equation. All right, so this is if and only if mod z square plus 2z minus z0 square. So it's important that you note this is if and only if, not just an implication. And that's basically because root 2 is is a positive real number. So now we get z bar equals twice of z minus z naught times z bar minus z naught bar, which gives us twice of z naught bar z minus z naught z bar plus z naught bar, which gives which is equivalent to 0 equals z bar minus so let me write it this way, plus minus 2 z naught bar z plus minus 2 z naught whole bar z, oh sorry, let me, this is whole bar and this is not with, this is without a bar, so we get that. Yeah, I had made a mistake here. This was z naught bar and I had not written it that way. Okay, so now just call this w and call that m, or rather sorry, call this w and call that m. Then what you see is this equation, and therefore it is a circle. So the set of points satisfying that is satisfying this is precisely the set of points satisfying that, and therefore this is the locus of such points P is a circle. All right. So very nice application of complex numbers to geometry. And with that, I want to end this lecture. As usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.